The label on a bottle states that it contains 330 milliliters of orange juice. The capacity of the orange juice in these bottles is normally distributed with a mean of 365 milliliters and a standard deviation of 20 milliliters. In a batch of 100 bottles, how many bottles are expected to have less than the labeled amount? So that would be less than 330. So we can see that this is normally distributed. The mean is 365 and the standard deviation is 20. So to start off with, let's work out the probability of x being less than 330. So that's just calculator work. So let's just clear everything that we've got here just to make some space. And then we're going for a normal distribution. So normal CDF, and the lower, we'll take that to be negative infinity, and the upper is going to be 330 because we're going less than 330. We know that sigma was 20 and that mu was 365, so that's 0.04 and so on. And we want 100 bottles, so that's just going to be 100 times the 0.04 and so on. So we're just going to take that last answer and multiply it by 100. And that's 4.00 and so on. So we'll say 4 bottles. Samples of 10 bottles are tested and the mean capacity for each sample is recorded. State the distribution for the sample means and their mean and standard deviation. So this is n equals 10. So we can say that x bar, that's the means, is going to be normally distributed. The mean is always the same, but with the standard deviation we take the standard deviation and divide it by the square root of n. So it's going to be that, so the mean is 365 and the standard deviation is 20 divided by root 10. Calculate the probability that the sample mean is less than 360 milliliters. So that's just calculator work again. So we're going for the normal CDF and less than 360, so we're going to go from negative infinity up to 360, and sigma this time is going to be 20 divided by the square root of 10, and the mean is 365, and that gives me 0.215. Determine the sample size so there is a 99% chance that the sample mean is no more than 5 millimeters from the population mean. Think about when we make a confidence interval. We would take our mean, which is 365, plus or minus k sigma over root n. So here we want k sigma over root n to be less than 5. Now our k value for a 99% chance, you may know that, it may be on your notes, but if you don't, we can find it using the inverse distribution. Tau setting left. If there's 99% in the middle, there's 1% at either 1% between both ends, so 0.5% at each end, which is 0.05, giving us 0.005, was what we actually wanted, giving us a k value of 2.576. So 2.576. Now we know sigma was 20. We don't know root n. That's got to be less than 5. So that gives me that root n is greater than 2.576 times 20 divided by 5. So root n needs to be more than 2.576 times 20 divided by 5. So that's 10.304. So n needs to be more than this last answer squared, 106 point something. N has to be a whole number, so we'll say n equals 107.